Spex takes uncorrected seg-Y CDP gathers and makes corrected gathers and velocity spectrums and conventional stacks and automatic velocity independent stacks. And in addition to conventional NMO corrections, it can make stretch-free NMO corrections. So let's see it working. Right, so let's look at one of the supplied seg-Y files, demo 4. And we'll start by making an uncorrected CDP gather display. So we can see it's a fairly deep water line. Water bottom is about 1.6, 1.7. It doesn't look like it needs a mute, but we'll pick one anyway. Now to pick mutes, we'll use the right mouse button. Something like that perhaps. And we could now make a velocity spectrum and pick a velocity function and make a corrected CDP gather display and pick a mute on that, and then make a conventional stack, or we can just straight away make a stack, an automatic stack. So here's a stack made without any velocity information. Now for each window, the mouse's location is shown on the Windows status bar. If I double click on any stacked trace, for example here, if I double click, then I generate a CDP gather, an uncorrected CDP gather at that location, 859. So double click's uncorrected, control click is corrected. So let's make a corrected CDP gather here. And shift click is spectrum. So let's make a velocity spectrum, perhaps here. And we can pick a velocity on that again with the right mouse button. Maybe something like that. And let's pick another function over here somewhere, perhaps here. So shift click again, and we could copy this function here and paste it over here. And we can delete pics with the control right button. And pick a function over here. And let's see how that looks. To make a conventional stack, we need to switch the color off and we need to make sure we're doing conventional NMO, otherwise we'll get stretch free NMO, which we'll look at later. So let's make a conventional stack. We can flip between the various windows by F11 and F12. We could put them side by side, they're small enough. And compare them that way. So it's pretty obvious. Here's the water bottom. It's pretty obvious that that's the water bottom multiple. And over here too. Okay, let's look at our landline demo 3. And we'll make an uncorrected gather. Very poor data. We'll pick a mute on this. Something like that. A velocity spectrum. I'll pick a velocity function. And we'll make a corrected gather. And we'll pick a mute on this as well. Put the windows back where they belong. F7. And let's make a stack. So this is the velocity location. It's not easy to see what's going on. Well, let's pick another velocity function over here maybe. So shift click. And here we'll pick a function. So now we've got two velocity functions, and we'll make another stack. And we'll flip between those two stacks. So it's certainly an improvement. It's still very unclear. Well, let's get rid of these velocity functions altogether. So we'll delete that. And we'll delete that. So now we've got no velocity functions. And let's go to the parameters and switch on the color. And we're going to make an automatic stack. see how that compares. And again we'll flip between those stacks. And now we can see what's happening. Maybe there's some sort of disturbance up shallow. Well, now every time we open a file we get the SegY headers listed. That's the text headers. Oops. And the binary header. And we get some trace headers as well, the first two and the last two. Along with the seg standard description. If we go down to the bottom, we can see that those items which are asterisked are used by Spex always. So let's see which items are asterisked in the trace headers. Well, there's only CDP number. And the offset. That's really all that Spex needs. But if we have some more information, these items which have a hash by the side of them, then we can do residual statics. So let's see where they are. Here they are. It's the source and X and Y coordinates and the receiver X and Y coordinates. And they're non-zero, they're defined, so we can compute and apply residual statics on this line. Let's do that. So we go to parameters, find residual statics and click on compute. And once again we click stack. And this time we get two stacks. The first one is a plain stack without any residual statics, and the last one, the latest one, has residual statics applied. So there's not much difference really. A little bit clearer maybe. Appended to the last stack are the shot correlations and the receiver correlations. Each correlation is shown closest to its CDP, and those correlations which are not reliable get tagged with a square wave. So we can see there's a static error there and there. The statics are listed in comma separated value files which go straight into Excel. That's all documented in the help. One more thing, let's look at Windows Task Manager. If we look at the performance tag, now this laptop is a quad core, and each core has 2 threads, So we've got 8 threads. If we go to parameters, we have the option of using all 8 threads if we want. Let's see what happens if we do that. We'll look at the CPU usage. So let's run this last stack again. And here we can see it's using 100% of the CPUs and all the threads. And perhaps that's not a very good idea if we've got other jobs running on the computer, so it might be wise to leave a couple of threads free. Okay, well let's look at another of the supplied SegWi files, demo 2. Now this is a synthetic line, and here we're going to be looking at NMO stretch. So let's look at an uncorrected gather. And a velocity spectrum. And we'll look at the parameters to make sure that we have conventional NMO checked, otherwise it would be stretch free. So let's make a corrected gather. And here's the problem, because the data, the trace between here and here has to be stretched to fill the output trace from here to here without stretching it. So it's quite a puzzle. Well, if we remember this display and we go back to the parameters and switch off conventional NMO, we'll have stretch free NMO. Let's see how that looks. So there it is. Let's make a stack. Let's make a stack with conventional NMO. So here's a stack. The line's a line of dipping data. And let's just make a comparison with stretch free NMO. So we'll make another stack stretch free. And we can compare those two stacks. So let's look at the last of the 4 supplied SegWi files, demo 1. There's another line of synthetic data, and we're going to be looking at some uncorrected gathers. So F2 and F3 we'll be looking at for a moment. F2, we'll look at CDP number 1, and here it is, and CDP number 20, and here it is, and CDP number 40. And here it is. So as the CDP numbers increase, so does the noise, and it's a line of 7 arbitrarily dipping events. They have no geophysical meaning whatsoever. It's just hyperbolas and noise. Let's look at a spectrum. And we'll pick a velocity function on that. And see how that stacks. Let's just check. We want conventional NMO. So we'll stack that and see what we get. here's the velocity location where we picked our function, and here's where the noise is really very high. Let's look here. Well, rather than single valued time velocity functions, we can actually have velocity bands like this. And let's make that very wide and see how that stacks up. The only difference, by the way, between the various stacks we've been looking at so far is dynamics and possibly statics. There's been no mixing from CDP to CDP. Well, let's start some mixing. We can choose the amount of mixing, and the coherency, the mixing is based on the dips, we say, and the coherency is based on pre-stack data, so it's got a lot of statistics to look at. So let's make a mixed stack. So what else? Well, we can see that the various stacks, we can save them as bitmaps or segway files. If we look at the parameters, we can save the gathers as segway files as well. That's the corrected gathers. Oh yes, we can, let's find the spectrum. We can change the gain on these spectrums. Well, we can save them as bitmaps as well. Let's change the gain. Also we can, now each time we make a stack, Spex generates an equivalent hotshot flow. So this is the latest stack we made. We can put this flow straight into hotshot without any modification, because hotshot has a routine called respex, which is the exact equivalent of Spex. And in hotshot, well, we can do whatever we want. We can add annotations to the section displays or whatever we want. And that's it. So thanks for watching.